Example 25. Solve the following system of differential equation using Laplace transform. So we have x prime equals negative x minus 3y and y prime equals negative x plus y, given x naught equal to 0, y naught equals 1. Okay, so this is actually x naught equal to 0 and this is y naught equals 1. And then I put the transform of derivative here for our quick view, okay, for our quick reference. And okay, first up, we need to write the equation in terms of Laplace transform, okay, and then substitute the initial conditions. Okay, so for the first equation, so we have the Laplace to the x prime. Okay, so I just put the x prime, but you should know x prime means x prime t. Okay, the function in terms of t equals. So at the right hand side, we have the Laplace to the negative x minus 3 Laplace of y. Okay, and for the second equation, we have the Laplace for the y prime equals to the Laplace to the negative x plus Laplace to the y, okay, at the right hand side. And for simplicity, I will denote this notation. So I'm going to use I'm going to replace xs by just x and ys to be just y, okay, for simplicity. So I'm going to assume for this one xs and ys here. And now the Laplace of x prime, okay, according to the formula that we have here, it's supposed to be sxs minus x naught. Okay, so I can write this one now to be as x. Okay, it's like what I have here. Okay, I assume x as in my writing to be x. Okay, sx minus x naught. So I can put straight away x as sx minus 0. Okay, so this one equals at the right hand side. Okay, so the Laplace of negative x can be written as negative to the Laplace of x. Laplace of x is x. Okay, minus 3 Laplace of y is capital Y. Okay, and similarly for y prime, so I'm going to have s y minus y naught. My y naught is 1. Okay, equals, so at the right hand side we have negative x plus y. Okay, and rearrange the equation so that the terms with the x and y we need to put on the left hand side. Okay, term without the x and y we put on the right hand side because our intention is to apply the Cramer's rule after this. Okay, so from the first equation we can see we can factor out the x. Okay, so we factor out the x, then in the bracket we have s plus 1. Okay, and then we have plus 3y. So at the right hand side it's supposed to be 0. And for the second equation, we only have one term with the x. Okay, so we have x. Okay, but for the y we have two terms. So for the y, so we can factor out. So we have y. So in the bracket we have s minus 1. At the right hand side we have 1. Okay, so now we have a system of linear equation. Okay, so those two equations now, in terms of metric system, it is s plus 1 and 3. This is 1, s minus 1. Okay, and the variables are x and y. Okay, at the right hand side it is 0 and 1. Alright, so now we are going to apply the Cramer's rule to write our xs and ys. Okay, so this is actually our x and this is our y. Okay, so now the x is given by the Cramer's rule, so we put the denominator first. So denominator is s plus 1, 1, 3, s minus 1. So at the top, in the first column, we put the right hand side value, which is 0 and 1. So at the second column, it remains as 3s minus 1. Okay, so by the determinant process, so we have 0 minus 3 at the top. At the bottom, we have s plus 1 times s minus 1 minus 3. Okay, so simplify the expression. So for this one, we have negative 3 over s squared minus 4. Okay, so that is our xs. Okay, so similarly for the ys, okay, by the Cramer's rule, ys or y is given by, okay, so, okay, go a bit lower. Yeah, so for the y, it is now, the denominator should be the same. So the denominator should be s squared minus 4. Okay, so you can straight away put this one to be s squared minus 4. So at the top, in the second column, you put your right hand side value, which is 0 and 1. Okay, so it means in the first column, it should be the coefficient of x. So this is s plus 1 and 1. So at the top, we have s plus 1 minus 0. That is s plus 1 over s squared minus 4. Okay, so we have now the x and y. Okay, so to get the xt and yt, so basically we need to find the inverse transform for the x and also the inverse transform for the y. Okay, so it means xt is the inverse to the xs, which is the inverse to the, what we have here, this one. So this is xs, negative 3 over s squared minus 4. Okay, so this is just negative 3 inverse of s squared minus 2 squared. So at the top here, it should be 2 when we map to the a over s squared minus a squared. Okay, but to get back the negative 3 at the top, so we need to multiply with the 1 over 2. So this is just now by the table. You can refer to the table. This is just negative 3 over 2. We take out the 1 over 2, put together with the negative 3 in the front. Then the inverse to the 2 over s squared minus 2 squared is just shine 2t. So this is our solution for the xt. Okay, but for the yt, it is the inverse Laplace to the ys. So it is now the inverse to the s plus 1 over s squared minus 4, which can be written in the form of 2 inverse, the inverse to the s over s squared minus 4, plus the inverse to the 1 over s squared minus 4. Okay, so we need to solve 2 inverse here. So we just refer to our table, see which one should we map to. So this is for the first expression here. This is straightforward. This is cos 2t. Okay, and for this one, now we need to rewrite in terms of s square minus 2 square. So at the top it should be 2, but then to get back the 1, we need to multiply with the 1 over 2. Okay, so this is now 1 over 2 inverse of 2 over s square minus 2 square is again sine 2t. So that is our xt and yt. Okay, so those are the steps that we need to follow in order to solve the system of differential equation. Okay, well, again, the bulk of the work is actually here. Okay, but for this one, it's just a simple expression. The xs and ys, okay, can be easily mapped to the table, but in a different problem, the solution here may take few mapping, few manipulation and mapping process. Okay, so we'll see the second example in solving the system. Okay, second example. Okay, example 26 on page 37 in your lecture notes. So the first order linear system, given that x and y are functions of t such that x prime equals 1 plus y and then y prime equals 2 delta. Okay, we have direct delta here. 2 direct delta t minus 1 plus 4x. Okay, given. So this one is x naught equal to 0 and this is basically y naught equals -1. Okay, so first of all, we rewrite the equations that we have in terms of Laplace notation. So we have Laplace of x prime equals Laplace of 1 plus Laplace of y. And for the second equation, Laplace of y prime equals 2 Laplace of delta t minus 1 plus 4 Laplace of x. Okay, and by the transformation formula, the Laplace of x prime is as capital X. Okay, so this capital X is actually x in terms of s. Okay, I'll just denote as x. Sx minus x naught. So at the right hand side, Laplace of 1 is 1 over s. Okay, so we just solve straight away. And Laplace of y is the ys. So just write as capital Y. And for the second equation, Laplace of y prime is s y, capital Y, minus the y naught equals to Laplace of direct delta t minus 1. So you refer to the table. Laplace of direct delta t minus a is exponent negative as. So we have exponent negative s in this case. Plus for Laplace of x is capital XS. Okay, so 4x. And then this x naught and y naught. X naught is 0, y naught is -1. Okay, so what we have is s x. Okay, so now we put all the terms with the with the x and y to be at the left. So we have sx minus y equals 1 over s. And for the second equation, we have negative 4x. Okay, put the 4x to be on the left. So it is negative 4x now. And then we have plus s y. So at the right, okay, terms without the x and y. So we have 2 exponent negative s minus 1. Okay, because this negative 1 with this negative is positive, but when we put on the right hand side, it becomes negative 1. Okay, so in terms of matrix form, then we can see that this is actually S, negative 1, negative 4, S. Okay, so the variables are X and Y. So at the right hand side, we have 1 over S and then 2 exponent negative S minus 1. Okay, so now the Cramer's part. Okay, by the Cramer's rule, by the Cramer's, okay, so xs or x can be written as, so the denominator now is s, negative 4, negative 1, and s. And at the top, we have 1 over s. So this one, okay, be careful because we have a non-constant expression. So 1 over s, 2 exponent negative s minus 1. So this is actually on the first column. In the second column, okay, remain as the coefficient of y, which is negative 1 and s. Okay, so the process of finding the determinant. So at the top, we have 1 over s times s, which is 1. Okay, minus with the negative 2 exponent negative s plus 1. So careful on the arithmetic process. So at the bottom, we have s squared minus 4. Okay, so this one now can be cancelled out. Okay, so we have at the top, we have 2 exponent negative s over s squared minus 4. So this is our xs. And for the y, okay, we know that the denominator should be the same. So we have s squared minus 4. So at the top, okay, the first column, okay, remains as s and negative 4. But for the second column, we put the right hand side term of our equation, which is 1 over s, 2 exponent negative s minus 1. Okay, so this one equals, so at the top we have s times 2 exponent negative s minus 1. So we have 2s exponent negative s minus s minus 4 over s. Minus 4 over s, so it is positive 4 over s. So careful. And then at the top, it is s squared minus 4. Okay, so a bit of so few terms at the top. Okay, so we can imagine later we are going to find the inverse to the y, means we need to get the inverse to this term here. So it is advisable to separate the terms at the top to be into few terms so that it is easier for us to find the inverse later. Okay, so what I mean, we rewrite the expression, the fraction, to be into three individual fraction. Okay, so we have 2s exponent negative s over s squared minus 4 minus s over s squared minus 4, and lastly we have plus 4 over s squared minus 4. So we have 4 over s square minus 4. Okay, so that is y, okay, or ys. Okay, now this is the last step, okay, which is the longest steps of all steps that we have. So now our aim is to get the xt. So xt is the inverse to the xs, which means it is the inverse to the 2 exponent negative s over s squared minus 4. Okay, so this one, okay, so you need to refer to the table and see which one is the most similar. Okay, most similar expression to what you have on the right hand side of the table. So again, whenever you have expression, okay, in terms of exponent, okay, exponent times something, then it should be mapped to, so this one actually mapped to the inverse of exponent negative as fs, where the answer should be in the form of f t minus a h t minus a. Okay, so I hope you can do the process in details. Okay, so I just put straight away here. It is, okay, by the mapping, it is 2. This is shine 2 t minus 1 h t minus 1. Okay, because by the mapping we know that our a is negative, our a is 1. Okay, so the fs is 2 over s square minus 4. Okay, which can be mapped to 2 over a over s square minus a square, which is shine. Okay, shine 2t. And so that is our xt. And then for the yt, so this is a bit longer because we have 3 expression here in terms for the ys. So yt is the inverse to the, okay, so 3 terms. 2s exponent negative s over s squared minus 4 minus the inverse to the s over s squared minus 4 plus, okay, 4, okay, you can take out the 4, the inverse to the 1 over s squared minus 4. Okay, so for each one of these, okay, you solve individually, see see in the table which one that you should map to. So I put the just for your reference here, this one should be mapped to, again, map to exponent negative ASFS. And this one is straight forward mapping. This is A mapping to A over S square minus A square. And this one you need to rewrite further in terms of partial fraction. Okay, in terms of partial fraction. So I hope for the partial fraction here, you can get, this is negative 1 over 4 over s plus 1 over 8 over s minus 2 plus 1 over 8 over s plus 2 in terms of partial fraction. Okay, so cut the story short, the yt here is 2 cos 2 t minus 1 h t minus 1. Okay, minus, so for the second expression here is just cos 2t, and for the third one this is 4 times negative 1 over 4 plus 1 over 8 exponent 2t plus 1 over 8 exponent negative 2t. Okay, so with the reference that I've put here, so I hope you can work out the details. Okay, so how do you get from here to here, and how do you get from here to here? Okay, so at the end you get your xt and yt. Okay, so what we are looking for is for the expression for this one, for your x, and the expression for your y. Okay, so I hope you will go through again, okay, all the process that we have here. Make sure you can understand every single bit of it, because this is most likely to be asked in your final exam. All right. So basically we have come to the end of this chapter. Okay, so next week we will start with chapter 4, okay, the Fourier series.